the series that you'll run into, there's two types: alternating, which have negatives and positives, and non-alternating. If it's non-alternating, you do the first non-alternating test, which is a definition test. Does the limit as n approaches infinity of u of n go to what? 0. That's the first thing you always do. Because if it goes to 1/2, that means to infinity it's 1/2 plus 1/2 plus 1/2 plus 1/2, which would go to infinity. Or even if it were negative 1/2, which it couldn't be because they're positive terms. But let's say it went to 2. 2, 2, 2, 2, that would go. So the first thing it has to do is go to 0. Then what you would do next is do the ratio test. Two things you have to do. Positive terms, go the limit, n approaches infinity of u of n plus 1 over u of n equal to L. If L is less than 1, it converges, right? So when we did the convergence of series, trying to see if the power series converges, what did we did this u of n plus 1 over u of n, and we had something like x over 4. What did we set it less than? 1, right? Because that's the limit. So no new news there. It all connects. So the limit is less than 1. If the limit's greater than 1, it diverges. But sometimes, and it's annoying, it's equal to 1. Well, if it's equal to 1, then you're going to use the integral test. 3 things there you have to know: positive terms, decreasing interval, continuous on the interval. If you go from, I guess it'd be a to infinity, and you get some constant k, not infinity, then it converges by the integral test. And then we had another test, but it's kind of separate from all these. The flow chart is limit to infinity equals 0, ratio test, integral test. Those were the boom, 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 flow chart. But we sometimes are asked to use the comparison test. So these are positive terms for u and v. You just take u over v. And if the limit as that goes to infinity is a constant, what is, if that equaled infinity, is that converging or diverging? If this ratio is infinity, it's diverging. Now, it doesn't matter which order you go. So you could have v of n over u of n or u of n over v of n. So what's infinity over 5? Infinity. But what's 5 over infinity? 0. So the no-nos here are infinity and what else? 0. You don't want to have 0 for the comparison test. If you get a constant, then they're both convergent or both divergent, and you have to know one of them. And the one that we usually knew was this one. 1 over n. What was that? 1/2 plus 1/3 plus 1/4. Divergent. That one diverges. And you can prove it by taking the integral from 1 to infinity of 1 over n dn. What is the integral of 1 over n dn? Natural log of n. When you go from 1 to infinity, do you see how the natural log of infinity is infinity? So that's how you know that the harmonic series diverges. So any combination of that, like let's say it's 11 over n or 4 over n, all of those are going to go to diverge. Now, what about something like 1 over n squared? That's going to converge. So we had this 1 over n to the p. If p was equal to 1, it diverged. If it were less than or equal to 1, it diverged. So what does it need to converge? Greater than 1. Yep, 2 will work. How about 1.1? I've seen that on tests before. 1.01, 1.2. All those will diverge. If it's greater than 1, converge. Converge. Sam, is that what you needed? And then for the alternating series, there were only 2 things that we did. We took the difference of these terms, actually the absolute value of the difference, and if they were less than 0, that means they're decreasing. Decreasing means that if it decreases to a nice value that we like, when it alternates, it should go to 0. And that's the second criteria. Decreasing and limit to infinity is 0. And that's the same as what we had with the very first criteria for non-alternating. But this is final. Any other ratio tests for these? No. But you do need to say it's alternating. Things like -1 to the n or sine of pi n, things like that will be alternating. Yeah, Sydney. You do. Wonderfully said. Yep, and then converge conditionally means you do the alternating, and absolutely means non-alternating, which includes alternating. And then this is the part people ask me all the time. What about the error? Non-alternating is we found that the error was somewhere between n to infinity of u of n and n plus 1 to infinity of u of n dn. See, they're going to be decreasing terms like this. If you go to the n, and here's n plus 1. If you start here at the n, you're going to get that. If you start at the n plus 1, which one's going to be high and which one's going to be low? The one that starts with n, will that be high or low? High, because it's the left edge. And then this one's going to be low because it's the right edge. So this is high, left edge, this is low. Good with that? And then this is the partial sum. So if we added up to here, you added all these up to n, and then you added the error, that would be an estimation of it, which is great. So it says find the n where partial sum is within this. You'd integrate from n to infinity and set it equal to that, and you'd find the n. Then alternating is way easier. All you have to do is the error is less than the next term. And the next term is whatever you use for that alternating. So if the error is less than the next term, sometimes the question will ask this, and it's what I call a word formula. The word formula is, when is the error smaller than 0.001? When is the next term less than 0.01? That's different than the reality that the error is less than. The word question is, when is this less than? And we ran into that with the problems a few times. And it says find n where the error is 10 to the negative 6. So what you're going to do is you're going to say find n when it's less than 10 to the negative 6. Okay, that next term is 1 over 2 to the n plus 1, correct? So you'd flip it over and you get 2 to the n plus 1 is equal to 10 to the 6th. And then this is 2 to the n times 2. You're going to divide by 2. 2 to the n is equal to 10 to the 6th over 2. Is that 5 to the 6th? 10 over 2? No. Base to the 6th over 2. That's totally different. This is 1/2 of 10 to the 6th, not 1/2 of the base. All right, so then I'm just curious, how would you find n? Make my day. Very good. Take the natural log of both sides. You'll get n is equal to the natural log of 10 to the 6th divided by 2. And that is divided by 2, not the natural log. And then you round up to get that.